Welcome back after the break, and we were busy discussing question 2.5.6. Explain the impact of an urban development at points A, B, and C on the drainage density. Now, I've shown you where A, B, and C is. Now, urban settlement, what do we know? We look at drainage basin X, it's already high density. And what influence will the urban settlements have on drainage density X? Now let's quickly go and answer that question. Now first of all, like I've mentioned, we use artificial surfaces. Now when we build urban settlements, what do we tend to do? We tend to deforestate. We tend to remove the vegetation. And we already discussed that vegetation promotes infiltration. It will actually create a lower density. So immediately, the first effect of the urban settlement will create a higher drainage density. Now, the second reason there will be a higher drainage density is because of first of all, let's say the higher drainage density is created because of deforestation. Now the second reason is because of the artificial surface that we use. For instance, the tar road surfaces. And that will lead eventually to more streams being created because of this artificial surfaces, and because of the deforestation, it creates more streams. So that means when we look at drainage basin X, that it's going to even have a greater drainage density because of the settlements that took place at A, B, and C. Our next question, let's quickly go and have a look at our next question. 2.6 illustrates river capture. Now before we're going to continue with river capture, I prefer the term stream piracy. Now what do we know about piracy? Pirate stealing from someone else. Okay, so if we look at river capture, is when one river steals water from another river. Now if we look at this diagram quickly, and we just quickly go and look at some clues. And I'm going to draw on this diagram. Now over here we got a river flowing. They're flowing parallel with one another. River T, and there's river S. Okay. Now I'm going to make this river T a little bit of thicker line. And what I try to represent over here has got more volume of water than river S. And then there's an indication of A, B, and C. Now, if you look at your keys over here, there's hard rock and soft rock. Now, very importantly over here, hard rock is more resistant to erosion than soft rock. So the type of erosion that we're going to experience here with stream piracy is also known as backwards erosion. So basically what happens, if you look over here, this river over here, T, it's got much more volume of water. So the velocity of water is going to be greater. So the erosion capabilities of river T is greater than river S. Now if I can quickly draw a side profile, transverse profile from S to T, it's going to look at the following. Over here, we have river S. Do you see it's much more narrower? And then we got river T. It's at a steeper gradient and the volume of water is greater than S. Now, very importantly, what separates this one river from another river is the watershed. Now, river T has got greater volume of water, as you can see over there, than S, so it's got more erosional capabilities. So what does this start to do between the watershed? It starts to erode through the watershed in the form of backward erosion. And because, as you can see, river T is at a lower altitude than river S, water can't flow from T to S, can't flow upwards. So what's going to happen? S is going to flow into T. So what did T actually do? It stole the water from S, creating the misfit stream over there, the stream elbow situated at A, the wind cap over there, and this is the misfit stream, wind cap, stream elbow, and that was the captive stream. Now let's quickly look at the questions involved over here. Is river S or river T the captive river? Now if you quickly look at the question over there, if you look at the diagram, river T is the captive river, is the pirate river, is the one stealing the water from river S. So the correct answer over there will be river T. Name the features of river capture that developed at points A, B, and C. Now, I've just mentioned them, but let's go and write them down. A is the stream elbow. For instance, over here, you can see it looks like the shape of an elbow. B is the wind gap, is where the river physically dries up. And C is the misfit stream. A, stream elbow. B is the wind gap. And C is the misfit stream. The next question, 2.6.3, give two possible reasons why the tributary of river T eroded through the watershed. Now, I explained that earlier as well. Why did T created backward erosion over there and eroded straight through to S? Now, like I've mentioned, if you look at the river T, it's got greater volume of water. Maybe it's flowing over less resistant type of rock, or because it's at a lower altitude. So let's go and answer that question quickly. So we can say that river T is flowing at a steeper gradient. So that means the velocity is going to be greater because the water is going to flow faster, and when the water is flowing faster, it's got more erosional capabilities. Another reason is because river T might experience higher precipitation. So this drainage basin on this side over here experience higher precipitation, means there's a higher rainfall area. And that's the reason why the volume of water is greater. Higher rainfall area. And another reason that we can mention, because of softer bedrock, so it erodes easier. Okay, if we quickly look at 2.6.4, write a short paragraph in which you explain the impact of river capture on the sustainability of the river and ecosystem. Now, this is the paragraph questions that you will experience in every single question. Remember, you need to answer this question in paragraph format. I'm going to write it in bullet form, but please, when you do answer this question, you need to write it in paragraph format, or else you're going to be penalized for that. Now, if you look at that, explain the impact of river capture on the sustainability of the river on the ecosystem. Now, the ecosystem involves everything that depends on the water in this river. How is it going to influence it? Now, obviously, definitely it's going to have a negative influence, especially on a river that got captured. So let's quickly have a look at some of the reasons why. Now, it's going to increase the volume of the pirate stream. So if we go back to the diagram, you will see now that river S is flowing river T, the volume is going to increase even more. So that might lead to rejuvenation. Now there's going to be more downward erosion. There's going to be more downward erosion because the volume of water increased, and that will lead to rejuvenation. What does rejuvenation mean again, great halves? It's the ability of a river to get more energy, to regain energy. Another reason that we're going to go have a look at, the ecosystems will be disrupted further along the Misfit Stream. Oops, just a little bit too far. The ecosystems will be disrupted because now where the stream dries up, where are they going to get the water from? Another reason that we can add over here, the sustainability of the Misfit Stream is reduced. And what else can we add over here to this paragraph question? Plant life and animal life will be disrupted. At the Misfit Stream. Now, for instance, if we just look back at the diagram, now keep in mind, this is the Misfit Stream over there. Now, the plant life and animal life in this area, what needs to happen over there, plant life might be destroyed because they don't have enough water, and we're going to experience a migration of animals because there's not enough water to provide for them. This is all we got time for this episode. Stay tuned for the next episode where we're going to continue with question 3 and question 4. Thank you for watching. See you next time around.